Leave Insert differentiation tutorial higher level, and these questions involve differentiating trigonometric functions and with the use of the product rule, the quotient rule and the chain rule. So if you have a function like y equals x squared sine of x, okay, so the x squared makes it different. It's not a number, so therefore you have to use your u by v. So u is x squared, v is the sine of x. So du dx is 2x, dv dx, when you differentiate sine of x, you get cosine of x. dy dx is u dv dx plus v du dx. So dy dx is x squared by du dx, which is cosine of x, plus v, which is sine of x, by du dx, which is 2x. So to simplify it, dy dx is equal to x squared cosine of x plus 2x sine of x. And if you wanted, you could simplify it by taking out the x. So x into x cosine of x plus 2 into sine of x. And that would be that finished. The next example would be if you had something like y is equal to sine of x all over x. Okay, so clearly it's a quotient rule, so it's sine of x divided by x. It's something other than a number on the bottom. So u is equal to x, so u is equal to sine of x and v is equal to x. du dx is cos of x, dv dx is equal to 1. Now quotient rule, dy dx is equal to v du dx minus u dv dx all over v squared. So dy dx is v, which is x, by the cosine of x minus u, which is sine of x, by dv dx, which is 1, all over v squared, which is x, all to be squared. So dy dx is x cosine of x minus sine of x all over x squared. Now the next example, which is quite common when differentiating trigonometric functions, is the use of the chain rule. It's used quite a lot with trig functions. So a simple example would be if you had something like cosine cubed of x. Now if you look at it closely there, the power is on the cos, okay? It's on the cosine, not on the x squared, on the cosine. So I would advise that to be written as the cosine of x all to be cubed. The cosine of x all to be cubed. Now, as you can see, it looks like a chain rule. So dy dx is equal to 3 cos of x, and take 1 away from your power to the power of 2 by, when you differentiate the cosine of x, you get minus sine of x. So the finished differential is minus 3 sine of x cos squared of x. Now just to look at also the way it can come up with a square root. So if you had the square root of the cosine of 2x, not forgetting that that surd can be turned into an indice, y is equal to the cosine of 2x to the power of a half, and then you proceed normally with the chain rule. dy dx is a half into the cosine of 2x all to the power of a half minus 1, which is minus a half, by the differential of your function, what's inside your bracket, which is differentiate cos of 2x, you get minus sine of 2x, and don't forget to differentiate the 2x and you get 2. So dy dx is equal to a half by 2, which is 1, so that's going to leave us minus sine of 2x by the cosine of 2x to the power of minus a half is 1 over the cosine of 2x to the power of a half. And bringing it back into third form, dy dx is minus sine of 2x by 1 is minus sine of 2x all over to the power of a half is the same as to the square root of the cos of 2x.